I just got a delivery of a Zeeweii digital oscilloscope. I guess that's how you pronounce it. I'm not entirely sure. I saw this thing on AliExpress and I thought by myself, let's check it out. It's 2.8-inch handheld digital oscilloscope, 120 M bandwidth, megahertz one presumes, dual channel oscilloscope signal generator, XY mode, whatever that means. What does it say over here? Frequency, sine wave 0 to 10 megahertz, other 0 to 2 megahertz, resolution 0.1 hertz, amplitude 2.5 volts. Basic R&D, car repair, okay. XY mode can display lascivious graphics or VI curves. Okay, sounds interesting. It's just a standard XY mode on the oscilloscope, I guess. 10 millivolt per division. Vertical sensitivity can help you measure power, noise, weak signals, video output. The screen can be projected to a TV or other large screens with only one signal cable. We're going to test that. That's what it looks like. I was sort of intrigued with this thing. I actually got it for $77, but now the price has already gone up to $86. I think this inflation thing is getting out of hand, but still. All right, so what else does it say? It has powerful functions like adopt ARM and FPGA chip co-location, and also output various waveforms. Provides high-speed signal acquisition, high-speed data processing, smooth use evidence functions. Wide applications can be used for such single chip debugging. Sampling rate 500 M. I guess that is 500 mega samples per second or something. Battery, one lithium battery, 4000 milliamp hours included. Basic features. 2 channels, auto coupling. High performance processor. Got an FPGA and an ARM processor. Even got fast Fourier transforms. We're going to test that. Waveform save view. One click to save the screen waveform. Enter the waveform preview page. Click the thumbnail to observe the full screen, and up to 250 waveforms can be saved. Alright, we're going to test that. Screen can be projected to a TV or other larger screens with only one AV signal cable. I believe it is, for what I saw on the comments, that it is an old-fashioned AV cable and not HDMI. Well, I don't see anything about being able to download software or anything, so So let's go and check it out. So here it is. I haven't opened it yet, so this is the first time. Comes with a little case. Oh, look at that, it even has a manual. So to use a manual, it actually has English on there, so we will hope for the best that it's not English as in Chinese. Bad translations. I will have a look at that probably by myself. It looks okay. The manual does, that is. Okay, so what have we got in here? We've got a little screwdriver thing for adjustments. We've got some probes. What does the probe say? 100 megahertz. They don't look too bad. Actually feel nicer than the probes that came with my Siglent oscilloscope, which I'm actually not that happy with. They seem to be intermittent or something. Okay, so what is this? What does that say? Scan the QR code with your mobile phone to see how to make it yourself. Somehow little plugs and some heat shrink tubing and some wires. They didn't solder it up, so I'll have to scan the QR code and see what they say. Not even sure what this is exactly for, but we'll find out. Here is a USB-C cable, presumably to charge it. And what else is here? We've got a, oh, this is their audio video cable. That's what I said, you know, it's not HDMI. I'll have to look if I actually have anything. Maybe the PC behind me, the TV behind me has an input for that. Okay, well, here's the device. Two B and C connectors. Let me see if I can maybe zoom in a little bit for you guys. All right, save 50% power. Channel 1, channel 2, F1 millivolts, nanoseconds, volts, run, stop, auto, menu, single. Okay, so at the bottom here, and I guess maybe I should charge this thing up before I do a full test on it. This is a USB 3 cable. Oh, I see. There's two little sockets there. That's presumably for the where these leads have to go in, but you have to make them up yourself. And here is a socket, presumably for that audio video cable. Oh, it does have some power. Well, I am going to set this thing up and have a look at the features. I'll let it charge for a while, and we'll see where we go from there. Okay, so let's have a look at the signal generator of ability of this thing. So you're supposed to hit the F1 button, and then this comes up, and from here you can actually change the frequency. Let's have a look now. Kilohertz. Let's select like 100 kilohertz, like so. And these are all the different types of waveforms that it has available. Let's start with a square wave, and we turn it on, run stop. There we go. And we say OK, and then we hit the auto button, and there we go. Let's do the same thing on the big oscilloscope. All right. So according to that, we got 2.64 volts peak to peak on the big oscilloscope. Because don't forget, we're on the 10 times probe, and I don't have a set for 10 times. I think there might be a setting in there somewhere, but I don't know where to find it easily, so I'm leaving it as it is. This one, however, says peak to peak 2.5 volts, and which is actually what it is specified as, so I don't know. In any case, you can change the ratio, but it seems like the it gets an offset when you do that. In any case, this is kind of interesting. The Sequent microscope, oscilloscope, it seems to be bad with triggering. It's always like I've got another oscilloscope, an analog one, and it always is able to lock in by itself. But this thing, you always have to fiddle with it. Anyways, let's go back to 50%. Of course, you can make it wider, but you see how the DC voltage changes. I've got it set for DC. Anyway, no matter. Go back to 50, and this is a sine wave. So what happens when you go and change the percentage? Oh, I'm on the wrong. Let's stay on 100 kilohertz. Okay, so when you're dealing with sine waves, it ignores the percentage. This is a kind of like a random noise sort of signal. Here is a signal that looks a bit like a heartbeat. The little oscilloscope is able to kind of lock into it better than the big one. But nevertheless, I'm not going to fiddle with that. This is like a looks like that percentage thing. The width, you know, is only works on square waves probably. Yeah, I don't see it have an effect on any of the other waveforms. This is like a it's like a half wave rectified kind of thing. Yeah, also doesn't do anything. This is a ramp, triangle wave. Oh, look, triangle wave does respond to the. You can actually turn it into a bit of a ramp. Interesting. Like the square wave. So that's what it has. Okay, let's leave it on square wave and 50%. All right. So that is. So I've got the output of the thing fed back into itself, so that it's looking at it is looking at its own waveforms that it is generating. Now let's have a look at other features. There's cursors here. So if you hold down this button here, will it? Okay. So here we have a vertical cursor. We've got a full wave there, and it tells me that it's 100 kilohertz and 10 microseconds, which is correct. So now if I turn that off, now we have the horizontal cursor. 2.4 volts. 1.22. So you can use that for measurements. All right. Falling edge, rising edge with a trigger. If you hit this button and you say OK, it actually centers the waveform in the middle of the screen. This is for so what I'm doing is hitting these buttons here. So it takes a little bit of remembering what if you hit volts or millivolts, that actually goes higher or up or lower, seconds and nanoseconds. It'll make the time base go down, and time goes up. And you can actually save waveforms up to 250, I believe. And then there is a mode where you can put this thing in, where the USB, it's got a USB port here at the bottom. The USB port can be used to plug into a computer, and then it'll look like a drive, and then you can download the waveforms that you've captured. Round stop. This is for auto. It actually, when you feed a signal in there and you hit auto, it automatically centers it and selects a trigger for it. There is a menu, and the menu goes like that. You can actually select the coupling, DC or AC, for both channels, channel 2, channel 1. You can put measurements on the bottom over here. There are measurements here. So we've got frequency, peak to peak, and RMS selected. You can select other, like duty cycles and so on. Trigger is auto, rise. This is channel 1 or channel 2. Trigger mode, trigger level. I haven't played with those yet. Display is persistent or not persistent. And here's XY mode, which we're going to try out with a device that I have got for curve tracing. And here is some stuff, some sort of calibration, fast Fourier transform rather. And let's try that out. Okay, so here we got a fast Fourier transform. Now right now I'm feeding it with 100 kilohertz sine wave, and you can see there's just a few little peaks here, 1 and 2. And if I change that to a sine wave, a square wave, you can now see all the little harmonics over here. 1, 2, 3, 4, in diminishing amplitude, which is what you would expect to see for a square wave. So it does work. However, I don't know how you would, like normally on an oscilloscope, you can say, okay, show me where the peaks are, what the frequencies are, and stuff like that. I'm not aware that you can actually do anything like that. Right now it is set to 10 microsecond per division. Perhaps you can kind of work it out from that. I'm not quite sure. In any case, but it does work, and it can show you how pure your waveforms are. Here is a triangle wave or ramp wave sort of thing, and you can see again there's different frequencies involved here, but it's different. It goes down quicker. So anyway, interesting. It does work. So it does have fast Fourier transform. You actually go into the menu here, and I think, oh yeah, there it was in auxiliary. So you can turn fast Fourier transform, turn it off, and you can actually choose whether you want it logarithmic, this is what I had, or linear, or music. Well, if I'm going to choose music, it's not going to. I probably should change the frequency because for audio frequency. Okay, here's 10 kilohertz. Anyway, this is what it has. Oh, I just want to try something here. Set this to music. Yeah, that's what I thought. If you select different, let's turn the menu off. If you select different bandwidth here, you can actually see more. Time base, I set it to. So now you can see a sort of like a frequency response there. That could be useful actually. Okay, so I got my new Regal oscilloscope going in the background there, and I have the little pocket oscilloscope going, and I'm feeding it a 80 megahertz sine wave. And as you can see on the Regal scope, it's about 1 volt peak to peak, but the little oscilloscope there is actually reporting 700 and something volts peak to peak. So in actual fact, that is the 3 dB down point, roughly, and so therefore we can conclude that it has about 80 megahertz bandwidth with the probe set to 10 times, and not the 120 megahertz that they are reporting on the website when you buy them. And as you've seen before, another odd thing about it is that at roughly at 100 megahertz there is some internal resonance somewhere in a filter or whatever, and the signal completely disappears. So let me turn it up. So there you go. This is exactly 100 megahertz, and I've seen this happen in some of the other little oscilloscopes that they sell, and they must be using the same front end chips and stuff like that. There is something wrong with them that they attenuate exactly at 100 megahertz. Now if I turn it up higher, you'll see the signal coming back, but so this is about 140 megahertz, and the signal came back, but still it's reporting a frequency of about 58 megahertz, and the peak to peak should be about 600, over 600 millivolts, and it's reporting 247. So therefore, although you can see that it's a sine wave, but in anything above 80 megahertz, you really can't trust it, and therefore the bandwidth of it is definitely 80 megahertz and not 120. Okay, so what do I think about this little pocket oscilloscope? Obviously, the features that are advertised on the website are not correct. It is not as sensitive as they say, and it doesn't have 120 megahertz bandwidth, only about 80, as we have seen. However, It is battery operated, like right now it's running off the battery. It has a function generator in it. Right now I am running the oscilloscope of its own built-in function generator, 123 kilohertz square wave, and it has output. I plugged in the AV output into this little device here that I bought for about less than $8, and it has a HDMI output. I will plug it in and we will show what it looks like on the screen. So that's what it looks like when the AV output goes through my adapter and gets converted to HDMI. It is low resolution, but then that is because the screen in there is low resolution as well. I wish they would have a version with a higher resolution screen. It would make it a little bit more useful, but it doesn't matter now. I have a Regal oscilloscope with HDMI output, which is nice and sharp, so I'll be using that for my videos. But I thought I would just show what it would look like if you plug this thing into a TV with AV input or convert it to HDMI. I think all in all the little device is useful. It's got a little function generator in there, and it has 80 megahertz bandwidth, which is not bad, and it is battery operated, so when I go out in the field, if you want to look at something, it will be handy. The probes actually at 10% say that they are good for up to 600 volts, so could even use it on mains power, and especially since it's not connected to ground, so you can actually probe things without blowing stuff up. So I think it is useful at times, I'm sure. So that's all I have to report on it. Until next time.